Hi friends. So today we are gonna cover this paper attention in natural language processing and in previous lecture or previous paper we have discussed about from where who have proposed the concept of attention first. So in encoder decoder based model, so yesterday we have seen this paper neural machine translation by jointly learning to align and translate. So in this paper what happened, they proposed that attention mechanism will help to remember a long sequence. So there was a drawback of encoder decoder model for that if the encoder summary is bad, encoder make bad summary, the translation will also uh, will be bad. All right. So this corresponding translation is based on this how good the summary is from this encoder model. That is in last layer. Context vector is saved in last layer of encoder. Okay, so that was first problem, and another problem was it was never unable to remember longer sequences due to its balancing and exploding gradient problem. So that was also a problem. So it was only remember the part which it has just seen. Okay, so and also there was another problem to give more, because we cannot give more importance to a particular bird from that sequence, because as we can read this complete sentence and we can say okay, here translation is important word, here machine neural machine is important word. So in this way they have some importance of every keyword. So but before this paper there was no concept of attention. Right. So this paper proposes a concept of attention, and this also because that paper is based on this paper, so that's why I'm reminding this. So here uh, this encoder decoder, the problem with this encoder decoder was this, and it was having some layers, so that if you want to follow this you can go through the previous lecture. Here we will also cover this. So okay, so let's come back to our today's paper. That was yesterday papers, and I thought let's have a quick view of that paper, so that this paper will be easy to understand. So right, so here same concept, but that is in attention and natural language processing. So that is also somewhat saying that the paper is work on sentence, that means that is also a natural language phenomena that they have proposed in previous paper, but this paper is more specific to this attention and natural language processing. So here they have use the previous model from this paper, neural machine translation paper, and they have used the same encoder decoder and this concept context vector concept and this model encoder in general model, and this all complete things they have taken from this. And after that, so and over this paper, the previous paper, they have proposed there some of the new things. So that is they have defined a unified model for attention architecture. So they have given a unified model for attention architecture in NLP, with a focus on those designed to work with a vector representation of textual data. Okay, so another thing is they have proposed a taxonomy attention models according to 4 dimensions. So what are these 4 dimensions? The representation of the input, that means what is the representation of the input, and the compatibility of function and distribution function and multiplicity of the input and the output. So this is 4 dimensions in which the taxonomy of the attention model is based on. So they have also uses present the example of how prior information can be exploited in attention problem, because that was problem in the previous paper, that in encoder decoder model, that was problem that it was suffer from this exploit exploitation, gradient exploitation, right? So here they have so that prior information can be exploited in the attention models, and discuss and then they have discussed ongoing research effort and open challenges in this area. So they have provided the first extensive categorization of the past body of literature where excited domains, right? So this is about attention and what is attention. And so attention, we already know, focus on particular word that have more importance. Okay. And after that they have said that how means what was other problems. So the problems were quite similar to that papers, because the paper means uh, and they are in introduction they are saying that what before that paper what was problem, and in natural language processing. So this in many problems involve the processing of natural language processing, the element composing the source text and categorized by having each a different relevant to the task at hand. So there were problem like a problem that involved the processing of NLP. So there was quite problems in aspect based sentiment analysis. Keywords such as good and bad could be relevant to some aspect under consideration, but not to others. So this was problem. It yes, and good and bad cannot be always good and bad. It can be changed according to um, according to context. Okay. So so this was one of the problems. And like this there was some of other problems they have discussed. So like a effective solution to such a problem should factor in notation to relevance, so that focus to computation means problems was that only that longer sequences cannot remember, and performance was not so good. So in this way they have discussed these things, and in that way, the neural architecture could automatically weight the relevance of any region of input, and takes such a weight into account while performing the main task. So the commonest solution to this problem is mechanism of attention. So the thing is they are giving the definition of attention. What is attention? Means giving automatic weight to a relevance of any region, particular region they are giving a weight of the input, and take such a weight into account while performing the main task. So that will depend that weight used while performing a main task, and play a major role while performing a main task. The commonest solution to this problem is attention. That definition they are calling that attention. So attention was first introduced in NLP for machine translation by this. So Vedana et al. So this paper we already have seen in previous. So that's what they are saying, that they have used the concept of Vedana et al. And they have proposed their unified model over that. So okay, so here they are saying that they have taken these things. I mean, already have been computer vision by this Larochelle and Hinton, and following the others in the biological retina. So this was mainly uh, here they are discussing that main approach is like from taken from this paper, because this paper is also saying that in a retina how attention work. So if we watch a complete image, or in which we can easily recognize without watching other things, we can without watching other things we can say okay, this image is of this thing. So there was no need of complete things, everything doesn't have a equal weight. So and that's what our retina focus. So this concept is also based on that. This retina is fixated on relevant part of optic array, while resolution falls on rapidly and centricity. So this was they are saying, so based on this concept they have proposed this concept And beside offering a performance gain, attention mechanisms may also be used to a tool for interpreting the behavior of neural architectures, which are notoriously difficult to understand. Yeah, difficult to understand. So the knowledge they gather is stored in numerical element, and that they provide any mean of interpretations by themselves, so it then become hard if not possible to pinpoint the reason behind the wrong output of a neural architecture. So this attention could provide a key to partially interpret and explain neural network behavior. Okay, so these are like highlights of how about this context. Like more attention have more weights, and more weight is shown by color, and this hard color, bold color, right? So you get what you pay for. So according to every word, um, this attention is taken into consideration, because this excellent have a more attention, location, price, return, cheap. So out of these word we can think that okay, this what they are talking about. Even if they are not getting to this complete sentences. So uh, watching on these sentences they can say okay, this is talking about hotel location. Okay, so here also, so hotel cleanliness means cleanest room, bed, clean bathroom. So this is context. This context is about hotel cleanness, and hotel services means they service excellent. So these keywords are more important to show that okay, this is in context of hotel, whether it is context of hotel location, whether it is context of cleanliness, and whether the sentence is or phrase is context of hotel services. So here also they have made a list of a lot of work that exploit the attention, and so they have grouped this thing according to category, like machine translation consists translation quality estimations, and like multimodal task contain image capturing. So a lot of work have exploit attention. These works exploit attention. And so in NLP, after an initial exploration by a number of sentiment paper, a fast-paced development of new attention model and attentive architecture ensued, resulting in a highly diversified landscape. Okay, so and this is about like importance of this attention, and how all these things are working. So in previous paper. Also I mean they are saying that these many of paper they have made a list of this paper. So they are saying that okay, this paper they are in this way they have uh, they have used this one concept of attention in this paper. So these are paper summarization how they have lot of paper that they have categorized into a group. This attention is taken attention was used. Okay, so here first thing is attention, because main thing is attention function. So here attention mechanism is like first example, machine translate alignment. The complete theory is taken from this paper only. um, a complete theory is taken from this here. And RNA encoder decoder and the learning and design translation. Okay, so this is taken from this place only. Let's we can go through this in short. So here output sequence they are saying that y input sequence is x, and the architecture of encoder decoder consists of an encoder followed by a decoder. So that is similar to, and it also have a bidirectional RNN recurrent neural network that computes the annotation of HI. So bidirectional RNN computes the annotation terms of HI for every input term xi. Okay, so for every input term xi they are taking they are this computing the annotation terms hi. So this is annotation terms for every input term xi. Okay. And then the decoder consists of two cascading elements, the attention function and RNN. So here in previous lecture also you have seen that here we have they have used the concept of attention function. Okay. So okay, so that's what they are saying. The decoder have two cascading function. This is decoder part. This complete is decoder part, and they are saying that it consists of attention function and a RNN. Okay, so at each time step t, the attention function produces an embedding CT of the input sequence. Okay, so CT क्या है? What is CT? CT is embedding. Okay, and T is every time step attention function produces embedding CT. So this CT embedding every time it is producing a embedding from this attention. That is that city, and that city they are calling it context vector. Okay, so here subsequent RNN categorized by hidden state ST. What is ST? ST is hidden state. So and then subsequent RNN categorized by hidden state computes from such embedding probability distribution over the possible output symbols pointing to the most probable symbol. So here concept of probability they are using for giving more weights, which have more weights means which have higher probability means higher weight for that word. So that's what they are taking computes from such an embedding, and this embedding is going here. So computes from this embedding a probability distribution over all the possible output symbols, okay, that are pointing to most probable output yi. Okay, and here for this probability they are using concept probability, prior probability. So so prior probability formula is p of yt given y1 to yt minus 1 up to that event, that is particular at time t is happening. So prior to that event, what all sequence was there, it is taking that and do a context vector. The context vector is obtained as follow: at each time step t, the attention function takes as input the previous hidden state of Rn st minus 1 and the annotation ht h1 to ht. Such input are processed through an alignment model and okay, so to obtain a set of scalar value eij, this is a set of scalar values that score the matching between the input and the inputs around position I and the output around position t. Okay, so these scores are then normalized through a softmax functions and so as to obtain a set of weight aij. So this function also we have seen in previous, like set of weight ATI. This is ATI and this is scalar value AT, score of matching between input and position, its position. So finally, the context vector CT is computed as a weighted sum of annotation HI based on the weighted AIJ. So this is taken from the paper of this paper. Okay, and then they have proposed their, so this complete A section are taken from paper of this paper neural machine translation paper, and then they have proposed a unified attention model. So let's go through this unified model attention model. So the characteristic of an attention model depends on the structure of data whereupon they operate and on the desired output structure. Okay, so that is simple thing. So unified model they have proposed is based on an extent of model proposed by Vaswani et al. So this particular model is an extension of Vaswani et al. Paper and Daniluk. article paper. Okay, so you can also check, you can go and check this model there also. So it comprises core parts shared by almost a totality of models found in the surveyed literature, and as well as some additional component that although not universally present is still found most of it is. Okay, so this is like, and then they are showing the how core attention model, this they are calling it as core attention model. And this core attention model have maps, this core attention mechanism map a sequence of k of dk and vector ki, dk vector ki, and ki is key to a distribution a of dk with ai. So here you can see this. So this is keys, all keys are here, and and this is a dimension nk into dk, and it maps to the distribution a of dk. So here is distribution a of dk. So that mapping is happening here. So k encode the data features, what k do. So this k encode our data features whereupon attention is computed, where attention is in the sections attention computed, and encodes the data feature where that data features that is already computed, attention is already computed. So for instance, k maps word or character embedding of the documents or internal state of a recurrent architecture, as it happens with the annotation hi in rnn search. So in some cases k could include multiple feature or representation of same object. And let's see. So here is a query vector, and query is going through this, and these keys are going through this, and this function is f, and this function is comparativity function, because four things we have seen previously, that the model is defined based on four things. That was compatibility, distribution, attention, weight. So in that way, the compatibility, here they are computing the compatibility, energy score, and distributions, and then calculating the attention weight. So so calculating this attention weight is a quite a summarized process. We can go through this, and you can check complete process how this is happening. And this is also a general attention model. Then after that they have presented. Okay, so this is general model and general attention model, and after that and they have deterministic versus probabilistic attention. To type of attention, they have described here what is deterministic and what is a probabilistic attention. So deterministic, and according to some literature, defines as deterministic attention models, and those models were context word whereupon attention is focused are deterministically selected. So this is definition of deterministic. And however, other author describe the first model is deterministic means soft. So what is deterministic means soft, to contrast it with stochastic attention, where the probabilistic distribution over weight is used to hardly sample a single input as context vector C, in particular following a reinforcement learning strategy. So if the weight A encodes a probability distribution, the stochastic attention model differs from their general model for sense of this two equation 8 and 9 that are replaced by the following equations. So the equation 8 and 9 then replaced by these two equations. Okay, and to avoid any potential confusion in the remainder of these articles, they will abstain from characterizing the attention model as deterministic, probabilistic, and stochastic. Three kind of categorization they have given for attention models, whether it is deterministic and whether it is probabilistic or whether it is stochastic. Okay. And uses and this section can include the use of attention. So attention enable us to estimate the relevance of input element with a means they are just saying that okay, every word have an importance in context vector. So that's what they are saying. And and they have given an example how this attention is important. Okay. So fourth is taxonomy for attention model. So this taxonomy in abstract they have said that taxonomy is based on four dimensions. So these are four dimensions. First, input representation, how input representation is. And then it is compatibility function, how compatibility function, and distribution function, and the number of distinct input output. Okay. So first is input representation. So in NLP, okay, let's say what is this compatibility function. Okay. And here is distribution function, and then multiplicity. Okay, right. So it's kind of a lengthy paper, but overall they have given a nice idea of attention. So okay, what else? And then challenges in the future directions. Okay. So I have given or I have given a basic idea of this paper, what and how this paper is taken, and what they have implemented. They have implemented a unified model based on four things. So that four things is explained here, and you can go through this. And it is really a nice paper to make your foundation for attention for NLP. So you can go through this complete paper. And this video is already 27 to 28 minutes, half an hour. So if I'll explain everything, it will go longer than this. So if you have any doubt, you can ask and comment. Till that, thank you so much. Again, if needed, I'll summarize this paper, and I'll summarize this models and this paper soon. Okay, bye bye.